So I gave you one where it's basically the directions were use the calculator to try to estimate the answer. So the way you do this is actually really easy. Turn your calculator on, press y equals. Okay? Here's where you're going to type in the two equations. It's always set for y equals. So all I have to type in is 4.7. The x button is right next to alpha. It looks like it says xt, and then there's a weird, looks like it's actually a theta symbol and an m. There's your x button, plus 2.1. Okay? And then press enter, and then type in the other equation. 1.6x minus 5.4. Everybody good so far? Yes, no, maybe so? Anybody not get that? So what do you... All right, so press the y equals button up in the top left. Yep. And that's where you get to this screen. The x button is right next to alpha. So just type in the 4.7, press the x, plus 2.1, press enter, and then type in the other equation. Okay? Once you have those typed in, you can just press graph. Now, sometimes you're going to get to the graph window and your window is all messed up, meaning sometimes it just doesn't look right. You can always get back to a standard 10 by 10, 10 by 10 graph. If it doesn't look right, go to zoom, and the sixth one down gives you a standard window. So just go down to where it says Z standard and press enter, and everybody should be on the same looking graph. Does everybody's graph look something like mine, other than mine's color? It says error, okay? It probably says syntax error, right? Or does it say invalid DIM? Go back to your y equals. Do you see up in the top where it says plot 1, plot 2, plot 3? You probably have one of those turned on from something else, and there's some other data it's trying to do. All you have to do is go up to where those are at and like hit enter, and you can turn those on and off. So turn that off, and then you should be able to get back to that graph. Good? All right. Now, you can look at it visually and try to find the answer, but this is a little hard to see, right? So there actually is a trace feature. So if you just press trace, you can move along those lines. Okay? Now, if you press up or down, it switches from one line to the other. Okay? So if by pressing X or up or down, you're basically jumping from one line to the other. If you hit left or right, it moves along that line. So I would move that down, and then once I think it's on the point, I would actually press like up and down again and see how much it changes. To me, that point right there looks like the answer. Because when I press up and down, those numbers aren't really changing. So that to me right there is the answer. So about negative 2.42, comma, negative 9.29. That's what I would predict as the answer. Is the graphing calculator going to be the most useful tool for us with these graphing methods? Why? Why do you say maybe? Is it easy to use? It really is. It really is easy to use. Why would this not? So there was a problem on your PMT that you just took, that little quiz, that was solving one of these, wasn't there? Was there one of those on the PMT? It was, here's the PMT you just took. Oh, wrong button. Number 4. Here's the PMT you just took. Come on, open up. You can do it. I got faith in you. Come on. Come on. Come on. You can do it. I got faith in you. Anytime, computer. What's going on? There it goes. All right. Where was it? Right here. Would the graphing calculator help us much with this problem? Why not? Right. In order to use the calculator, the biggest problem with using the calculator is if I want to graph this, if I want to use the graphing calculator to help with this problem, I have to put it in y equals. The calculator automatically puts it as y equals, meaning you cannot type this into your equation, into the calculator. It's just, you can't do it. You have to get this to the point where it says y equals. So that alone, that task, I know that's one of the things that we struggle with a little bit, where, we add the 2x to the other side, we divide by 3, so we'd get 2/3 x minus 1/3. This is what I would actually need to type in, okay? That alone is a bunch of extra work to do, because now I have to do it to both of them. There actually might be an easier way to do this in the long run. And then the other problem that you're going to run into is this. Let's take one that we actually did. What's another one that we did that has a nice answer? Like number 12, okay? So number 12 says y equals 1/2 x plus 2 and y equals negative x minus 1, okay? So there's our system. Can we use our graphing calculator to solve this one? Yeah, that would be pretty easy. So let's do that. We type that in. So we go to y equals. We clear out whatever we put in there before. How would you type in the 1/2 x plus 2? I would use 0.5. 0.5x plus 2. Press enter. And then I'd go, make sure you use the negative button down here for the x, minus 1. You can't use the minus x because it'll cause an error. So you have to type it in like that. Now press graph. And you should be able to get to your 2 lines. Does everybody get your 2 lines? Yes? Go ahead and press trace. Try to find the answer. Yes? Oh, get another one. Put that one by my computer. The battery's probably just died. Press trace. Anybody seeing a problem? So the answer to this question, actually is 2, 1. That is the answer to this question. One of the problems with these calculators is when you start moving along, the problem is the number of pixels. Do you guys know what a pixel is? So a pixel is like all the little lights that actually turn that into like a little TV screen. The number of pixels that are in this screen is a weird number. And then they want you to slide over. When you press over, it wants you to slide over a certain spot. And when the math of that in the behind the scenes as you move over, it creates a weird number. It won't let you find, like it is literally impossible right now, the way the window's set up, to get your cursor on the point 2, 1, isn't it? Like that is actually impossible to do. It will not go to the point 2, 1. You can get close and you can go, yeah, that's probably the answer. Sorry, yes, negative 2, 1. But it's actually impossible to get to that point, right? There is a solution to this. The solution, everybody press window. Do you see how it's negative 10 to 10, negative 10, 10? What that means is when you zoom in, it's zooming into a window of 10 to negative 10, 10 to negative 10. Okay? That's what that means, which is a nice, pretty window, right? The problem is with the number of pixels, it creates a bad problem where it won't let us go to those points. You can solve this. There is a solution. Change those 10s. So instead of negative 10, put negative 9.4. I think it's 9.4. It might be 9.7. We got to try it. Put it in 9.4. So put negative 9.4 in, positive 9.4. And then leave the x scale as 1. Put the y min as negative 9.4 and positive 9.4. Okay? Is that going to change my picture much? So basically what it means is instead of zooming into a window that's this big, well, now we're going to zoom in just a little bit to 9.4. So it's just going to be the slightest amount that we zoom in, right? Just a teeny tiny bit. Visually, it looks identical, doesn't it? Now press trace. And now when you press trace, it lets you get to those nice points. Right? Wait, mine didn't go there. You got close. Maybe it's 9.7. Hold on, let me try that. Zoom, a window. Is it? 9.4 and it gave me -2. Did it? Why won't mine do it? I swear it was 9.4. Let me try 9.7. I think it is 9.4. But mine's not working. I don't know why mine's not working. Maybe it's because mine's not a real, like a real calculator. It's the computer version. So I'm 99% sure it's 9.4 though. I don't know why mine didn't want to go there. Come on. Trace. Yeah, it must be because mine's not a real calculator. I think it is 9.4. Did yours work? Yeah, so it's a weird anomaly. The cause of it is the number of pixels in this little screen. So the workaround, it basically is because there isn't like 1,000 pixels going this way. They didn't make it 1,000. They made it like 940. Just a weird number. But because it's 940, if we use a factor of that like 9.4, that means when we slide over, it slides over a nice amount each time. So that's the workaround. Instead of making windows like 10 to 10, you do like 9.4 or negative 9.4. Instead of doing 100 to negative 100, you could do 94 to negative 94. The picture looks about the same, but all of a sudden the calculator works a little bit better. Just a weird little thing. So I didn't learn that until I got out of college, and I was like, what? I've been doing this for years, and I could have done that? That's a simple fix. And yeah, so kind of cool. Questions? And guys, I really don't think this is going to be that useful of a tool. I really don't. It's a nice little tool. It is a good way to kind of check your answers to make sure. Feel free to use the graphing calculator to do this, but I also don't think it is going to be the most useful tool to you, okay? Any questions on these? Why do you think I don't think the graphing calculator isn't going to be that useful of a tool? Well, what's the biggest problem? The biggest problem is most of your problems are going to start out like this. Which means if I want to use the graphing calculator, what do I absolutely have to do? I got to put in slope-intercept form. I have to solve for y. No question about it. And that's going to be one of the problems, okay? Yeah. Well, I mean, graphing calculator isn't going to be your best friend in this case. So, any other problems on the homework? What'd you guys get for 9? Yes or no? No? 10? Yes. 11? 11 was no. 11 should be no. We did 12 is negative 2, 1. What's 13? 3, 3, 14? Negative 4, 7. And 15? 3, negative 1. Is the graphing method pretty easy? Using graphing paper and doing it? Should be pretty easy. How about the story problems? Any problem there? Shocker. Words, scary words. So let's do 16. Angelo runs 7 miles a week and increases his distance by 1 mile each week. So what kind of equation could he run? Could we write? Y equals, what's he run? 7 miles a week, right? So 7 times x. And he increases each week, plus 1. Okay. And then, I lost my spot. Oh, there it is. Mark runs 4 miles a week and increases his distance by 2 miles each week. So what's his equation? Y equals 4x plus 2. Great. Find where they cross. So, we grab some graph paper. What were they? Y equals 7x plus 1. And y equals, 4x plus 2? All right, so first one starts up at 1. And where does it go? Up 1, 2, 3, 4, 5, 6, 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 2. And then the other one, so that's a pretty steep line. Starts at 2, right? And goes up 1, 2, 3, 4 over 1. I don't think that's right. I really don't think that's right. Did I write that right? Angelo runs 7 miles a week and increases his distance by 1 mile each week. Oh. That's not the right equation. That's a weird way to write that problem. So, how much, Mark? 1 week, how much does he run? He runs 7 miles, right? Week 2, how much is he going to write? How much is he going to run? Huh? No. He runs 7 miles and he's increasing it by 1. So 3 is going to be 9. And is that Angelo? Oh, sorry. Angelo. Sorry. Angelo is doing this. Yes? So his equation is actually, y equals 1x plus 7. Because the slope is 1, he's starting at 7. Wrote that backwards. What's Mark's equation then? Mark is starting where?
2x plus 4.
There you go, 2x plus 4. He's starting at 4 miles each week, and he's increasing by 2. So this is your equations. Sorry, I wrote that backwards. Read that backwards. So what is it? X plus 7 and 2x plus 4. So starting at 7, 1, 2, 3, 4, 5, 6, 7, up 1 over 1. Okay. The other one starts at 4, right? 1, 2, 3, 4, up 2 over 1, up 2 over 1, up 2 over 1. And then where do these two lines cross. Right here at what? 310. So that means they would cross, they would run the same after 3 weeks, and they'd be both running 10 miles. Fair enough? Sorry, read that one backwards. Anything else on this homework? Anything at all? All right, pass those up. Or actually, no, collect those and turn them in, will you? All right. Quick recap. All right, quick recap. Solve by graphing. Good, bad? What do we like? What do we don't like? When's the only time you'd ever even consider solve by graphing? It's got to start in slope-intercept form. If it's not starting in slope-intercept form, I'm going to have a different way, right? It's just, it can be time-consuming. What's one of the major problems with it? It's hard to be precise, right? So sometimes it works out nice, other times not so much. I don't think anyone in here in the end is going to say, if I give the test out and say you can use any method you want, I'd be shocked if anybody really uses graphing method very often. Maybe once in a while on the very easy questions where it's an easy slope-intercept, both of them are easy to graph. But other than that, we're going to have other methods. So today we're going to start this one. We're going to start another one is solve by substitution. Okay? So let me give you basic equations here. I'm going to start with an easy one. Yeah, go ahead. Kind of a bad time, but okay. All right. So here's your system, okay? Step one, it's solving by substitution. Step one, get one of the equations. Solved for x or y. It doesn't matter what it's solved for, but you have to get x or y by itself. In this system that I gave you, is that step already done for you? Yeah. Isn't that equation already solved for y? Cool. It doesn't matter which equation it is. It doesn't matter which variable it is. You just got to get one of the two equations where one of the two variables, the x or y, is by itself. Okay? Step two is you're going to substitute that equation into the other. So here's the key step. So this one's solved for y, right? So I'm going to rewrite the other equation. 2x plus y equals 5. But I'm not going to write the y. We know y is equal to this x minus 4, right? I'm going to replace the y in the other equation with x minus 4. Does everybody see how I did that? This is equal to y, right? So in the other equation where the y was, I replaced this with what we know y is equal to. Okay? What's significant about this equation now? What's the only thing in there? It's all x's now, right? Because it's all x's, I can now solve that equation. So, how many x's do I have? I have 2x plus x makes 3x. I still have that minus 4 equals 5. What should I do next? Add the 4 to the other side, so I got 3x equals 9. Divide by 3 and I get x equals 3. I know part of my answer. I know part of my answer here because what is my answer going to look like? What am I looking for? I'm still looking for the point where these are going to cross, right? I know one of these two numbers. Which one do I know now? I know the x. I know the x value is 3. Sometimes you're going to solve it and you're going to solve for y right away. We still have to find the y that goes with it. So step 4, plug your answer back into either equation. Okay? I recommend the spot that you plug it into is the spot you substituted. That one's already solved for y. Officially, it doesn't matter where you substitute it into, but I would substitute it right into here. So we have y equals x minus 4. We know the x is 3, so we go 3 minus 4. What's 3 minus 4? Negative 1. The answer is 3, negative 1. It really is that easy. Take out a sheet of paper. Take out a sheet of paper. You guys are going to do this one with me. All right, so let's say I go x plus 4y is equal to 6, and x plus y is equal to 3. There's my system of equations. Okay? This is what I have to solve. What is step number 1? What do I have to get here? I have to get one of these two equations, doesn't matter which one, to say x equals or y equals. Which one do you want to do? You want to do the bottom one? Fine. What do you want to make the bottom one say? Okay, so y would equal negative x plus 3. In this case, I actually had 3 really good choices. Could I have solved this one for x and said x equals negative y plus 3? That would work. I also could have solved this one for x really easily. The only thing I would not recommend doing is solve this one for y. Right? That would probably be the only poor choice in that. So we picked the second equation, and we got y by itself, right? Great. What's step 2? Substitute that into which equation? The other one. So I'm going to rewrite x plus 4y equals 6, right? But we're going to replace, or we're going to substitute the y. That y is going to become what? Negative x plus 3. It is important sometimes, most of the time, to use parentheses here. What's the next thing I have to do? Distribute. So I'd have x. 4 times negative x would be negative 4x. 4 times 3 would be 12 equals 6. X minus 4x would be negative 3x plus 12 equals 6. What's next? Subtract the 12, so I'd get negative 3x equals negative 6. Divide by negative 3 and you get positive 2. What does that mean about my answer? That means the x value is 2. How do you find the y that goes with it? You plug it in. And actually, you're going to have 3 choices of where you plug this into. Take out your paper, Abby. You can plug it in here. You can plug it in here. Or the spot I always typically recommend, right before you substitute it. This is going to be a nice spot because it's already solved for y. So I just got to plug it in, the negative x plus 3. And instead of the x, I plug in a 2. So you got to figure out what negative 2 plus 3 is. It is 1. So my answer is 2, 1. Should I be able to check my answer? Just like I did in the last section. Yeah. If you plug in a 2 here, is 2 plus 4 times 1 equal to 6? Yeah. Is 2 plus 1 3? Yes, absolutely. I know I have the right answer. It works in both. Okay? Now, again, I said in this problem that was x plus 4y equals 6 and x plus y equals 3. Would it have made a difference if we would have said, let's take this first equation, that x plus 4y equals 6, and get the x by itself? Where I would have what? Negative 4y plus 6, right? Where would I now substitute that into? The other equation, the x plus y equals 3. And again, I would replace the x, and what would I replace that x with? The negative 4y plus 6, right? Now here, I'm going to get a different answer, aren't I? That's a different equation than I solved. Well, what's negative 4y plus y? Negative 3y plus 6 equals 3. Minus the 6, negative 3, divide by negative 3, and what do you get? Wait a minute, I got 2 last time, didn't I? Why did I get a different answer? That's the y answer. That goes there, right? That is the same thing I got before, isn't it? That is, I got y is equal to 1 before, so you end up just getting the other answer first. It really doesn't matter if you solve for x or solve for y. It just matters of where you get it from, right? Or what variable are you solving first? If you plug that 1 right in for y, you'd get x equals negative 4 times 1. You're going to get negative 4 plus 6. So what does x equal? You get 2. So again, you're going to end up with the same answer. Step 1. What is I actually really like the substitution method. I think it's one of the best methods. I think it's one of the easiest methods. What's the general process? So let's say I give you, let's do a different one. Let's say I give you x plus 8y is equal to 16. So everybody write this one down. X equals 2y minus 4. Here's your system. What is step number 1? What's the first thing you always want to try to do? Get one equation. Does it matter which equation? Nope. Solved for what? Either x or y. Do I already have that done? Step 1 done. You don't have to do anything. What's step 2? Substitute. There's your homework. Wait. That seems really early. What was that bell for? Is that already the hour? All right.